Good morning, good afternoon, good evening, ladies and gentlemen, depending on where you are. My name is Kirill Kasavchenko. I am at Netskope, one of the leaders in cloud security. And before I dive into specifics of how we get secure access to cloud data, I'd like to do a very short intro and maybe share some funny facts from my life. I grew up in the city of St. Petersburg. And for those of you who don't know, this is the city where the average annual amount of sun hours, so the total sunshine during the year, so to speak, is equal to what you would see in London. So there is not that much sun really. And my kind of memories from the childhood is that I would see a lot of clouds all over my head. So when I would try to look at the stars, the sun, the moon, normally I would just see some gray clouds. And that's it. And the same analogy follows me as I'm working in network and security companies and trying to make sense of clouds over the last 10 years. The email services that we use these days are Office 365 and Gmail. Our messaging is Slack or maybe Facebook or maybe Hangouts. The CRM is Salesforce and so on and so on. And none of those apps are actually located on premises. They are all somewhere in clouds. So what we are trying to do at Netskope really is to understand how we see through those clouds, how we get control of the files and the data that we upload in clouds, and how we make sure they are protected. I'm not going to speak a lot about the marketing components or let's say the company itself, but I would like to talk to you about what are the typical approaches to secure data in the cloud. And first of all, what is the exact problem? How do we define the problem statement here? And speaking about problem statement, really what we are trying to do, we want our users to get access to application, as simple as that. Problem is that our users are not in one place these days. They are remote, they are in their offices, they work from anywhere. That might be their home, or maybe they are in a coffee shop, or maybe they are traveling on a road. Same as applications. Applications are not just in your data center. They are in a public cloud, such as Amazon or Azure, or maybe the applications are provided and delivered as software as a service. So again, think Salesforce, think Slack, think Gmail, which means if you try to visualize the traffic flow here, you would see a lot of different lines of different colors of very strange shapes and forms. And of course, sometimes when we want our remote users to get access, let's say to SaaS applications, we would first of all route them to our data center where they can exit through our existing perimeter security. And this is how they get access to external applications. So bottom line, this picture is very complicated. And when we try to apply security controls here, it gets only worse because this is what you get. You get different type of controls in different ways, shapes, and forms located pretty much everywhere. And it's very hard to make sense of that. The common problem I see here is, first of all, how we define a common policy. How do you make sure that regardless of where users are and what kind of application they access, they adhere to the same rules and they adhere to the same policy? How at the same time do we provide fast access to cloud and how we avoid redundant controls? So today I'm going to speak about possible approaches to solve those issues. And there are three approaches really. First of all, we can work with the endpoint data. So we can try to deploy solutions on the host itself that ingest, process data, operating system data, maybe log data in some sort of database, maybe in your CM. We process this data and we understand what is being uploaded to a cloud and whether there are any signs of malware or maybe any signs of DLP, data leakage in this traffic flow. And of course, there is a number of commercial solutions available in that space. So there are EDR solutions, there are endpoint DLPs, there is endpoint protection, EPP systems. So that's a very common way of doing things. At the same time, we can look from the other angle and we can work with the cloud data directly. So we can ingest login data, or maybe we can use API calls provided by your favorite SaaS or IaaS provider. For example, if you talk about AWS, Amazon Web Services, there are VPC flow logs There are S3 logs and there are ELB, Elastic Load Balancer logs. You can parse this data, you can ingest it somewhere, or you can use existing solutions such as API-based CASB, or maybe again some sort of CMs to understand based on the logging and API data what's going on with the cloud, what is happening there. Finally, a very common approach is to make sure that all your traffic goes through some centralized inline control where you apply different policies. We have been doing this for ages, actually. So everyone has some form of proxy, which are these days called secure web gateways. A similar functionality is available in inline CASBs right now, which are actually the same proxies, but they are targeting not just common web traffic, but different SaaS applications. And of course, next generation firewalls and firewalls themselves, they do implement some sort of functionality when it comes to application analysis in real time. So maybe let's take a closer look at these approaches and see what are pros and cons here. So if you talk about the endpoint data, of course, first thing that comes to my mind, there's a lot of additional context we can use. Because we are on the host itself, we can understand Windows registry, for example. We can understand the security posture of the host, whether all updates are installed and the antiviruses are installed, and so on and so on. So that's all possible. We know who is logged in, which user, serial number of the machine, and so on and so on. By definition, we've got no issues with encryption. That's obvious. But at the same time, endpoint data is very, very hard to get from specific form of devices. So if you think about corporate laptops, where you have GPO, for example, and policies, or you have MDM solutions, that's easy. But what about personal, private mobile phones of your employees? How do you get endpoint data from there? It might not even be possible due to legal or technical issues. And of course, this approach does not help us with the data which is already in the cloud, right? So once you deploy an endpoint, chances high that some cloud exchange has already happened, and some files are already uploaded to Google Drive or OneDrive or whatever you have got. And then probably we turn to the cloud data itself. So we start looking at the possibilities of the SaaS application itself, what kind of API it provides, what kind of login data can we ingest. And of course, it's quite easy to do because you don't need to mess with the endpoint. You don't need to intercept traffic. So it's not intrusive, really. It's easy to deploy. But at the same time, you can't deploy it everywhere. You can't deploy it for all the websites and all the applications that your users use and what they access. First of all, sometimes there is no API at all. And second, even if there were an API, how do you do this on the existing internet scale? That's not possible. So you can only do this for specific sanctioned applications. Think about Microsoft Teams, SharePoint, again, Google Workspace Suite, maybe Slack, Salesforce, GitHub, you name it. The good thing is that with that approach, you can get retrospective visibility. You can understand what is already in the cloud. You can pull this data and you can apply the same security policy to that data. And there's sort of misconception that this kind of access cannot be used for prevention. I would probably argue that to an extent it can be used. For example, Microsoft Teams supports notification using webhooks in REST. So each time when you upload a file, for example, to Teams chat, Teams would send an API notification to you. So if your system supports that, you can pull this file, you can apply your DLP or threat engines, and you can, for example, remove this file from a chat. Of course, it doesn't happen instantaneously. There are still seconds or maybe tens of seconds of delay, but this is still quite helpful to do prevention. And maybe as a first step, that's a good thing to do. Another thing which sometimes gets ignored is that because we work with the metadata, by definition, we are limited in terms of what we can see, and we are, so to speak, at the mercy of our cloud vendor. It's not like working with packets where you have access to all the possible raw data. When you inspect packets, there is nothing else you can do, right? So there is no data is missing here. All the data is in the packets. However, when you get logs or when you do API call, you only get the data that cloud vendor provides you with this delivery. So now talking about packets, of course, we need to talk about inline inspection, what we can do if we basically intercept all the traffic and we decrypt it. And of course, it can be used for prevention, as we all know. But the obvious downside here is that if we introduce additional latency, we might seriously impact user experience. And of course, it might be intrusive. So if something breaks, you might have issues from end user's point of view. It also depends on where we place this control. So if we have to use VPN to securely route all the traffic to a central location and then inspect it, that might be challenging from latency point of view, and I'm going to speak about this sometime later. To get access to clear text, of course, we have to do legal man in the middle. I think that's a very known topic, and we know how to do it. We know what to do with certificates. And of course, we know that a lot of applications will basically not allow us to do that due to certificate pinning. So your visibility into clear text is going to be limited. But even besides that, there are other challenges such as emergent transport protocols, such as HTTP2, HTTP3. QUIC has recently became RFC 9000. So it's very, very new protocol from standardization point of view. And we might expect this to be adopted by internet community. So your inline controls have to understand how you do deal with this traffic. How do you provide adequate performance when it comes to HTTP2 inspection? And this is something I want to talk more about. So in maybe 10 years ago, we would be dealing with TCP and older TLS versions such as 1.1 or 1.2. And that would really be our internet transport. We would be sending files over HTTP 1.1, which is encapsulated into TLS 1.2, and so on and so on. And it was all great until larger companies such as Google and Facebook and others, and CDNs mostly, they started to work on faster transport protocols, such as DTLS and QUIC. And this is how different transport ways such as HTTP version 2 and version 3 and WebRTC appeared. And now, as more and more cloud applications start to use those protocols for faster delivery, that becomes a challenge for security folks because, as I mentioned, our tools have to inspect this traffic. But moreover, not just we have to support the transport, we also have to understand what is inside this transport. From payload point of view, we used to deal with files or maybe with JavaScript, with the HTML content. Nowadays, browsers communicate with websites and with CDNs using different forms of APIs, and the data normally is sent as JSON structures. So unless we understand this API communication, and unless we understand this JSON language of the cloud, there is not that much we can do from cloud visibility point of view. So that really becomes a requirement for a modern security stack. Here, I will try to compare three approaches, and I'm not going to speak about the details of each line here. I just want to highlight that there is no single approach that closes all the checkpoints, and we have to somehow combine our approaches. We have to use data from endpoints. We also want to use some data from the cloud for data at rest, because we want to understand what is already in the cloud. We want to deploy this solution across all possible devices. So we have to keep in mind that on some devices, such as mobile phones, which are personal property of our employees, there is no way we can install an agent or a VPN client, and we have to think how do we ingest this traffic into to go through our security controls. Of course, we want to have access to clear text data. That's a must. And the last point, being non-intrusive, is something that we also have to keep in mind. And probably we could argue that the inline approach to an extent is also non-intrusive if things are ideal, if nothing breaks, and if there is not that much added latency. But let me speak about a very common scenario that I observe talking to our customers. And this use case is where your employees work from anywhere. For example, they work from home and they use Slack, for example, as a corporate messaging tool. So we want to be able to inspect the files they upload or download via Slack. Maybe we want to inspect it because of malware, maybe because of DLP engines. We want to make sure there is no confidential and sensitive data leakage. To do that, we would use VPN and forward all the traffic to our central location where we have all those nice shiny boxes that allow us to do decryption and inspection and so on and so on and so on. And you would argue maybe that's fine. And the latency that we impose here is not huge. And to an extent, I would agree. However, there are a couple of specific things that sometimes companies do not keep in mind when they design this kind of traffic flow. Those of us who work in networking, they know that this is called traffic trombone, a situation where your traffic makes a specific shape. And it results not only in increased load on headquarter resources, such as internet links and firewalls and VPNs. And you don't want to have increased load on your VPN, really, because a lot of us have had this experience last year when out of a sudden we had to go remote. We don't want this to happen anymore. But another thing that we learned is that even if your remote users are very close to your central office from distance point of view, maybe within 100 kilometers or 100 miles, and you might think that the latency is not great, so it's all good. The problem here is that internet does not always work as we want it to work. And I suggest you search for the thing which is called peering cores using your favorite search engine. Sometimes when you do a trace route between two adjacent buildings, your traffic might go through foreign point of presence or foreign internet exchange, simply because internet providers want it to be this way. That's cheaper for them, or that's how their traffic policy work, and so on and so on. So sometimes our remote employees might be just around the corner from distance point of view, but they are going to another country and then they return back just to get to our VPN concentrator. That's quite normal, unfortunately, these days. So how do we solve all this as Netskope, all these problems? Well, Netskope is not alone in this space, I must admit that. And our approach is that we are trying to build a cloud network. And I have a BGPS number for those of you who want to take a look at what our peering looks like and so on. So S55-256 is basically a collection of multiple points of presence across the globe, which we place so that the latency to the end users would be minimal. So they are in different parts of the world, in Europe, in Asia Pacific, Latin America, and the States, of course. And then we steer traffic from our corporate clients, from their remote users, and also from their personal devices to Netskope. How do we do this? Well, there are multiple ways. We can do tunnels. Of course, you can use proxies. And there is even such a thing as reverse proxy, where, for example, if you want to protect Microsoft Teams, then you use reverse proxy located in the Netskope cloud so that your mobile users would not even know that they go through Netskope. So we just forward their traffic to reverse proxy first, and then to Teams or to any other application. So by getting traffic into Netskope, we are able to apply different security mechanisms, and we call them security microservices. Of course, we have to decrypt traffic using TLS. There is threat protection and data protection components there, and so on and so on. And the overall vision here is that you would get exactly the same, if not better, security services from the cloud comparing to what you have on-prem. So that for your remote users, you would use the same security controls, DLP, firewalls, threats, client IDs, you name it, like they were in the office. So that's exactly what we are trying to build. Of course, to be competitive in this environment, we have to integrate with existing security tools. We see them. We have to support threat hunting by exchanging our threat information with existing solutions. And finally, for this to work, there should be a single console so that administrators can deploy the same policy across the whole network. So that's how we do it. And I think that's a very common approach that you see also in the market. And once you deploy something like that, once you get this initial visibility into the data that you exchange with cloud, of course, you start asking yourself, okay, what are the specific use cases I can solve right now? What I can do? So for example, which apps do my users use? What is my shadow IT, so to speak? Maybe there are any duplicate applications that are there for the same goal. So maybe there is a corporate procured, let's say, OneDrive from Microsoft, but at the same time, my employees prefer Dropbox or Box.com. And this is something you want to understand when you renew your subscriptions for cloud services. Then we need to understand what is sanctioned by your IT, what is not sanctioned. Because maybe there is a corporate Gmail that your users are using in your corporate domain, but at the same time, they continue using their private Gmail. And this is why you cannot simply block or allow Gmail, because we're talking about two totally separate instances and two separate use cases. We talk about corporate instance and the personal instance. And you want to know there's a traffic exchange between the two. And of course, you don't want to go through large CSVs or log files. You want this to be on a single page with something easy to understand from visual point of view, such as Sankey diagrams or top 10 diagrams, and so on and so on. And of course, you want to understand the typical data movement between your sanctioned and unsanctioned applications. So for example, if you get data from a specific cloud service, maybe you can upload this to your Yandex.Disk, if you're speaking about Russian services instance, but it's prohibited to be uploaded to your corporate CRM, something like that. So there are multiple scenarios that we can imagine, and it all comes with the visibility first. After you get this initial visibility, you might start thinking about DLP controls. How do I create DLP controls prevention across this space? And the key problem here is that sometimes companies try to deploy DLP on a very, very large scope. So they want to deploy it for a SaaS, for data that you observe in line, also the data that you pull using APIs, and then infrastructure as a service comes into play and normal websites. And the typical result here is that DLP results in a lot of alerts. There is alert fatigue, and no one is able to process that mess of data. So what we recommend to do here is, first of all, to reduce the surface area by implementing granular controls and making sure that you are not trying to boil the ocean. You are not trying to implement DLP everywhere. Maybe there are other tools here. So for example, if you know there are some malicious websites based on your threat intelligence feed or based on our intelligence feed, maybe we want to just block them because there is no valid use case while your users have to access those websites. Then, again, speaking about typical cloud apps such as cloud storage, maybe if we knew that there is a specific security rating for each application, we can block the application with the poorest rating because we know that they do not force any compliance, they do not store data in a good way, and they provide the data to the government, and so on and so on and so on. The data is not encrypted, and maybe we can just block it. Then, if we look at what is left, there are applications which are allowed by IT and applications which are not controlled, and therefore blocked by IT. For applications allowed by IT, and I had this example before, such as Gmail, for example, there are managed instances and there are unmanaged instances. And of course, there is difference. You might want to block uploads to unmanaged instances. And using the same logic, we can implement additional layers of controls before we even get to DLP. And this is how we prevent data leakage, actually. You do not necessarily need to inspect your files with DLP engines, with optical character recognitions and machine learning and whatever you've got, just because you can. Maybe there are easier tools based on granular controls. That's the idea here. And then, of course, you can start looking at DLP. And if you go that far, if you deploy DLP, and if you do this for public cloud specifically, you probably want to make sure that you follow common best practices when it comes to public clouds and SaaS applications. And I don't want to quote Gartner a lot because we are in a very technical conference. I appreciate that. But I think it's hard to disagree with this Gartner statement that these times, a lot of enterprises unknowingly or mistakenly expose private data just because of API or applications misconfiguration. I think basically each week we see an announcement that some company has leaked their data due to improper S3 configuration in AWS. That's a very common thing. And that's normal because public cloud is still new to some of us, so we have to learn it. What I'm trying to say here, there are very common, if not basic use cases that we can implement, such as prevent user compromise by enforcing multi-factor authentication, or ensure that our storage buckets are configured right, that they're not public. Or maybe you don't want to allow SSH from any IP address. Maybe you want to limit it to your kind of trusted IP addresses, to your office space. So all those things are not rocket science, really. And there's tons of best practices. Moreover, public clouds themselves, they have got tools for you so that you could automatically check all those configurations and implement maybe remediation. And if you don't want to use existing controls from public cloud because you prefer out-of-the-box solutions, then take a look what kind of CSPM offerings are available, where CSPM stands for Cloud Security Posture Management. And by the way, the same idea applies not just to public clouds, but also to SaaS applications. So software as a service. Again, similar use cases here, similar approaches. There are also best practices. There are also compliance checklists. And there are tools from SaaS themselves, such as Google Workspace Security Center and Microsoft Security Score. You're very welcome to use them. Should you want to use out-of-the-box solution, SSPM, SaaS Security Posture Management, is at your disposal. So what I'm trying to say, there are enough services here for you to make sure that you follow best common practices. Last but not least, what resonates a lot when we speak to CISOs, when they start moving into cloud and they understand that they need to get help from the employees themselves. And of course, security awareness is a very popular topic these days. So in the past, you would just block an employee from accessing this website or that website. These days, maybe we can be more clever and more intelligent. Maybe we can say, I want to take a look at the user security score and the application security score. And maybe at the organizational unit, if this user, for example, is a contractor and they're trying to do something which we don't fully like, maybe we just create a notification for them that says, dear user, dear contractor, you're trying to upload what seems to be confidential data to, let's say, Dropbox.com. And just to let you know, we have all supported Microsoft OneDrive or Microsoft SharePoint, where you have access to. Please use that because this is compliant. This is what you're supposed to do. And if for any reason you don't want to do that or you cannot do that, please provide a justification. And funny enough, a lot of employees actually do follow those requirements and they don't even bother providing justification. They just click stop and do what we ask them to do. So getting users to your site might help you a lot by educating the users and actually making them your first security perimeter, if you like. So I appreciate there was a lot of content, and just let me summarize the key points which we discussed today. First of all, when you start thinking about cloud migration, of course, expect there is not going to be a cloud, a single cloud tool. Maybe not initially, maybe midterm or long term, you're going to face multiple sorts of clouds. There is going to be software as a service, there is going to be platform as a service, infrastructure as a service, and of course, your own private cloud. And if you design security policy, you have to make sure you can deploy it across all those types of clouds. A lot of infrastructure in these clouds is not going to be available for you. You're not going to control the network, and to an extent, you're not going to control the security. So stop thinking about how you control traffic. Start thinking about how you control data. Thinking about the data, there is important to understand that there is not just data in motion, there is also data at rest. And to get the complete coverage, you have to think about both of them. Finally, if you advertise that your company is open to remote employees and you can do a lot for them, and they have the same rights as their office counterparts, you also have to follow this policy from IT and from security point of view. The user experience for remote employees should be the same as the user experience for office employees. So you have to think how your security and how your networking becomes friendly to remote employees. I thank you very much for your attention. And should you have any follow-up questions, my email is on the slide. I would be very happy to hear from you and get any feedback. Thanks a lot and goodbye.